The International Association of Electrical Inspectors, or IAEI, was established in 1898. It is a member-based organization with over 10,000 members worldwide. IAEI offers a variety of certification programs for electrical inspectors, including Certified Electrical Inspector, or C, and Master Electrical Inspector, or MA. IAEI conducts training and educational programs for electrical inspectors and collaborates with other organizations in the field of electrical safety. The International Code Council, or IAEC, was established in 1994. It is a non-profit organization that develops and maintains model codes for building construction. The ICC offers a variety of certification programs for building professionals, including electrical inspectors. These include Electrical Inspector, or I, and Electrical Inspector Pro, or I. ICC conducts training and educational programs for building professionals and provides resources and support to code officials. Both organizations are well recognized in the electrical industry. The IAEI is the older and more established organization, with a long history of providing certification and training for electrical inspectors. The ICC is a newer organization, but it has quickly become a leading provider of certification and training for building professionals. The choice of which organization to certify with depends on specific needs and preferences. However, both IAEI and ICC offer reputable and widely recognized certification programs for electrical inspectors. Electrical safety is paramount in any electrical installation. Ensuring that electrical systems are installed and maintained according to established codes and standards is crucial for preventing electrical hazards such as fires, shocks, and equipment failures. Certified electrical inspectors play a vital role in upholding these safety standards by verifying that electrical work complies with the applicable regulations. Their expertise helps to protect people and property from the potential dangers associated with electricity. The IAEI, with its long-standing history, has been instrumental in shaping the landscape of electrical safety. Through its certification programs, training initiatives, and collaborative efforts, the IAEI has consistently promoted best practices and knowledge sharing within the electrical inspection community. Its commitment to excellence has earned it a strong reputation and the respect of industry professionals worldwide. The IAEI, despite being a relatively newer organization, has made significant strides in the field of building safety. Its comprehensive suite of model codes covers a wide range of construction disciplines, including electrical systems. By offering certification programs and educational resources, the ICC has empowered building professionals to stay abreast of the latest code requirements and technological advancements. Its influence extends beyond the electrical domain, encompassing the entire building ecosystem. When choosing between IAEI and ICC certification, there are several factors to consider. Firstly, it's essential to evaluate the specific requirements of the jurisdiction in which an inspector intends to work. Some jurisdictions may recognize or prefer one organization's certification over the other. Therefore, it's crucial to research the local regulations and consult with relevant authorities to determine the most suitable option. Secondly, the scope of work and the type of inspections an inspector typically performs can influence the choice of certification. The IAEI's certifications may be more tailored to electrical inspections specifically, while the ICC certifications may offer a broader perspective encompassing various aspects of building construction. Inspectors should assess their career goals and the nature of their work to determine which certification aligns best with their professional objectives. Thirdly, the availability of training and educational resources can be a significant factor in the decision-making process. Both IAEI and ICC offer a range of courses, workshops, and online resources to help inspectors prepare for certification exams and stay updated on the latest code changes. Inspectors should explore the training options offered by each organization and choose the one that best suits their learning style and schedule. Fourthly, the cost of certification and membership should be taken into account. Both IAEI and ICC charge fees for certification exams, renewals, and membership. Inspectors should compare the fee structures of both organizations and consider their budget constraints when making their decision. Fifthly, the reputation and recognition of each organization within the electrical industry can influence career prospects. While both IAEI and ICC are well respected, some employers or clients may have a preference for one organization's certification over the other. Inspectors should research the preferences of their target employers or clients to make an informed decision. The electrical industry relies on a comprehensive system of codes and standards to ensure safety and consistency in electrical installations. These codes and standards provide a framework for designing, installing, and inspecting electrical systems, minimizing the risk of electrical hazards. Certified electrical inspectors play a critical role in enforcing these codes and standards, ensuring that electrical work complies with the applicable regulations. Their expertise and diligence help to maintain a safe electrical environment for everyone. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. It is developed and maintained by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Certified electrical inspectors must have a thorough understanding of the NEC to effectively perform their duties. In addition to the NEC, many states and local jurisdictions have their own electrical codes and regulations. These codes may be based on the NEC or may include additional requirements specific to the local environment. Certified electrical inspectors must be familiar with all applicable codes and regulations in their jurisdiction. The process of becoming a certified electrical inspector typically involves completing a training program, passing a certification exam, and meeting certain experience requirements. The training programs cover topics such as electrical theory, code interpretation, and inspection procedures. The certification exams assess the candidate's knowledge of electrical codes and standards. The experience requirements ensure that certified inspectors have practical experience in the field. Once certified, electrical inspectors are responsible for inspecting electrical installations to ensure compliance with applicable codes and standards. They review electrical plans, conduct on-site inspections, and issue permits and approvals. They also investigate electrical complaints and violations. The role of a certified electrical inspector is essential for maintaining electrical safety in buildings and communities. Their expertise and dedication help to prevent electrical hazards and protect lives and property. The electrical industry is constantly evolving, with new technologies and code changes emerging regularly. Certified electrical inspectors must stay up to date on these changes to effectively perform their duties. They can do this by attending training courses, reading industry publications, and participating in professional organizations. Continuous learning is essential for maintaining competence and ensuring the safety of electrical installations. Both the International Association of Electrical Inspectors and the International Code Council offer valuable resources and support for electrical inspectors. These organizations provide training programs, certification exams, and networking opportunities. By joining these organizations, electrical inspectors can enhance their knowledge, skills, and career prospects. In summary, choosing between IAEI and ICC certification depends on individual circumstances and preferences. Inspectors should consider their jurisdiction's requirements, scope of work, training needs, budget, and career goals. Both organizations offer reputable and widely recognized certification programs that can enhance an inspector's credibility and expertise. Regardless of which certification is chosen, the most important thing is to prioritize electrical safety and uphold the highest standards of professionalism. Understanding electrical systems requires knowledge of fundamental concepts. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. It is the driving force that pushes electrons through the circuit. Amperage is the rate of flow of electrical current, measured in amps. It represents the number of electrons passing a given point in the circuit per unit of time. Resistance is the opposition to the flow of electrical current, measured in ohms. It restricts the flow of electrons and converts electrical energy into heat. Ohm's law describes the relationship between voltage, current, and resistance. It states that voltage equals current multiplied by resistance, or volts equals amps times ohms. This law is fundamental to understanding and analyzing electrical circuits. Electrical power is the rate at which electrical energy is transferred or used, measured in watts. It is calculated by multiplying voltage by current, or watts equals volts times amps. Electrical energy is the total amount of electrical work done over a period of time, measured in kilowatt-hours. It is calculated by multiplying power by time, or kilowatt-hours equals watts times hours divided by 1000. Series circuits are circuits in which components are connected in a single path. The current is the same through all components in a series circuit. The total resistance is the sum of the individual resistances. Parallel circuits are circuits in which components are connected in multiple paths. The voltage is the same across all components in a parallel circuit. The total current is the sum of the individual currents. Grounding is the process of connecting electrical equipment to the earth, providing a low resistance path for fault current to flow back to the source. This helps to protect people from electric shock and prevent equipment damage. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. They interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. Wiring methods refer to the types of cables and conductors used to connect electrical equipment. The National Electrical Code specifies the allowable wiring methods for different applications. Electrical codes and standards are constantly evolving to reflect new technologies and safety concerns. It is important for electrical professionals to stay up to date on the latest code changes to ensure that their work is safe and compliant. Continuing education is essential for electrical professionals to maintain their competence and stay ahead of the curve. There are many resources available for electrical education, including online courses, trade schools, and professional organizations. By investing in their education, electrical professionals can enhance their skills and career prospects. The International Association of Electrical Inspectors and the International Code Council both offer valuable resources for electrical professionals. These organizations provide training programs, certification exams, and networking opportunities. By joining these organizations, electrical professionals can connect with their peers and advance their careers. Electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical hazards. By following safe electrical practices, we can protect ourselves and others from the dangers of electricity. Always use qualified electrical professionals for electrical work. Never attempt to repair electrical equipment unless you are qualified to do so. Be aware of electrical hazards in your home and workplace. Report any electrical problems to a qualified electrician. By working together, we can create a safer electrical environment for everyone. Understanding the National Electrical Code, or NEC, is crucial for electrical inspectors. The NEC provides comprehensive guidelines for electrical installations covering a wide range of topics from wiring methods to overcurrent protection. It is updated every 3 years to reflect new technologies and safety concerns. Inspectors must be familiar with the NEC to ensure that electrical installations comply with the applicable regulations. Article 90.1 of the NEC outlines the purpose and scope of the code. It states that the NEC is intended to provide practical safeguarding of persons and property from hazards arising from the use of electricity. Article 100 of the NEC defines the terms used throughout the code. It is important to understand these definitions to properly interpret the NEC requirements. Chapter 2 of the NEC covers wiring and protection. It includes requirements for wiring methods, conductor sizing, overcurrent protection, and grounding. Chapter 3 of the NEC covers wiring methods and materials. It includes requirements for different types of cables, conduits, and raceways. Chapter 4 of the NEC covers equipment for general use. It includes requirements for switches, receptacles, lighting fixtures, and appliances. Chapter 5 of the NEC covers special occupancies. It includes requirements for hazardous locations, healthcare facilities, and other special occupancies. Chapter 6 of the NEC covers special equipment. It includes requirements for elevators, cranes, and electric signs. Chapter 7 of the NEC covers special conditions. It includes requirements for emergency systems, standby power systems, and fire alarm systems. Chapter 8 of the NEC covers communications systems. It includes requirements for telephone, data, and cable television systems. Chapter 9 of the NEC contains tables and examples. These tables and examples are helpful for understanding and applying the NEC requirements. Annex of the NEC contains informational notes. These notes provide additional information and clarification on the NEC requirements. Annex B of the NEC contains application examples for ampacity calculation. Annex C of the NEC contains cable and conduit fill tables for conduit and tubing. Annex D of the NEC contains examples of calculations. Annex E of the NEC contains tables of conductor properties. Annex F of the NEC provides examples of cross-reference tables. Annex G of the NEC contains administration and enforcement. Annex H of the NEC contains administration and enforcement adoption information. Certified electrical inspectors must stay up to date on the latest NEC changes to effectively perform their duties. They can do this by attending training courses, reading industry publications, and participating in professional organizations. Continuous learning is essential for maintaining competence and ensuring the safety of electrical installations. In addition to the NEC, many states and local jurisdictions have their own electrical codes and regulations. These codes may be based on the NEC or may include additional requirements specific to the local environment. Certified electrical inspectors must be familiar with all applicable codes and regulations in their jurisdiction. Understanding grounding and bonding is essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, helping to protect people from electric shock and prevent equipment damage. Bonding is the process of connecting non-current carrying metal parts of electrical equipment together to create an electrically conductive path. This helps to equalize the potential between these parts, reducing the risk of electric shock. The grounding electrode system provides a connection to the earth. It typically consists of a ground rod, ground plate, or metal underground water pipe. The grounding electrode conductor connects the grounding electrode system to the equipment grounding bus in the service panel. The equipment grounding conductor provides a path for fault current to flow back to the source from non-current carrying metal parts of electrical equipment. The neutral conductor carries the unbalanced current from the load back to the source. It is typically grounded at the service entrance. Ground fault circuit interrupters, or GFCIs, are devices that protect people from electric shock by detecting small ground faults and interrupting the flow of current. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or SIs, are devices that protect against fires caused by arc faults. Arc faults are unintentional electrical discharges that can occur when insulation is damaged or wires are loose. SIs are required in many locations, such as bedrooms and living rooms. Surge protective devices, or SPDs, are devices that protect electrical equipment from voltage surges. Voltage surges can be caused by lightning, power grid switching, and other events. SPD are installed at the service entrance or at individual pieces of equipment. Proper grounding and bonding are essential for electrical safety. By following the NEC requirements for grounding and bonding, we can protect ourselves and others from the dangers of electricity. Electrical inspectors must carefully inspect grounding and bonding systems to ensure that they are properly installed and maintained. Understanding overcurrent protection is essential for electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. They interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. A circuit breaker is a device that automatically interrupts the flow of current when it exceeds a preset level. Circuit breakers can be reset after they trip. A fuse is a device that contains a fusible link that melts and interrupts the flow of current when it exceeds a preset level. Fuses must be replaced after they blow. The ampacity of a conductor is the maximum amount of current that it can safely carry. The ampacity of a conductor is determined by its size, insulation type, and ambient temperature. Overcurrent protection devices must be sized to protect the conductors that they serve. The National Electrical Code provides tables for determining the ampacity of conductors and the appropriate size of overcurrent protection devices. Short circuit current is the amount of current that flows in a circuit during a short circuit. Short circuit current can be very high and can cause significant damage to electrical equipment. Overcurrent protection devices must be able to interrupt the short circuit current without failing. Selective coordination is the practice of coordinating overcurrent protection devices so that only the device closest to the fault interrupts the flow of current. This helps to minimize the extent of the outage and prevent damage to other equipment. Proper overcurrent protection is essential for electrical safety. By following the NEC requirements for overcurrent protection, we can protect ourselves and others from the dangers of electricity. Electrical inspectors must carefully inspect overcurrent protection devices to ensure that they are properly sized and installed. Understanding wiring methods is essential for electrical safety. Wiring methods refer to the types of cables and conductors used to connect electrical equipment. The National Electrical Code specifies the allowable wiring methods for different applications. Non-metallic sheath cable, or NM cable, is a type of cable that consists of two or more insulated conductors enclosed in a non-metallic sheath. NM cable is commonly used for residential wiring. Underground feeder, or UF cable, is a type of cable that is similar to NM cable but is designed for underground use. UF cable is moisture resistant and can be buried directly in the ground. Electrical metallic tubing, or INT, is a type of metal conduit that is used to protect conductors. EMT is lightweight and easy to install. Rigid metal conduit, or RMC, is a type of metal conduit that is used for heavy-duty applications. RMC is strong and durable and can be used in hazardous locations. Liquid-type flexible metal conduit, or LFMC, is a type of flexible metal conduit that is used in wet locations. LFMC is resistant to moisture and corrosion. The National Electrical Code specifies the allowable wiring methods for different applications. The wiring method must be appropriate for the environment and the type of equipment being installed. Conductors must be properly sized to carry the load. The ampacity of a conductor is the maximum amount of current that it can safely carry. The ampacity of a conductor is determined by its size, insulation type, and ambient temperature. Conductors must be protected from physical damage. Conductors must be properly supported and secured. Proper wiring methods are essential for electrical safety. By following the NEC requirements for wiring methods, we can protect ourselves and others from the dangers of electricity. Electrical inspectors must carefully inspect wiring methods to ensure that they are properly installed and maintained. Understanding electrical equipment is essential for electrical safety. Electrical equipment includes a wide range of devices, such as switches, receptacles, lighting fixtures, and appliances. The National Electrical Code specifies the requirements for the installation and use of electrical equipment. Switches are used to control the flow of electricity to lighting fixtures and other equipment. Receptacles are used to provide a convenient connection point for electrical appliances. Lighting fixtures provide illumination. Appliances are devices that use electricity to perform a specific task. Electrical equipment must be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or all. This ensures that the equipment has been tested and meets safety standards. Electrical equipment must be installed according to the manufacturer's instructions. Electrical equipment must be properly grounded to prevent electric shock. Electrical equipment must be protected from physical damage. Electrical equipment must be properly maintained. Proper electrical equipment installation and maintenance are essential for electrical safety. By following the NEC requirements for electrical equipment, we can protect ourselves and others from the dangers of electricity. Electrical inspectors must carefully inspect electrical equipment to ensure that it is properly installed and maintained. Special occupancies have unique electrical requirements. Special occupancies include hazardous locations, healthcare facilities, and other areas where there is an increased risk of electrical hazards. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Healthcare facilities are areas where patients are treated with electrical equipment. The National Electrical Code specifies the special electrical requirements for these and other special occupancies. In hazardous locations, electrical equipment must be explosion-proof or intrinsically safe. Explosion-proof equipment is designed to contain an explosion within the enclosure. Intrinsically safe equipment is designed to not produce enough energy to ignite a flammable atmosphere. In healthcare facilities, electrical systems must be designed to minimize the risk of electric shock to patients and staff. Electrical equipment must be properly grounded and isolated. Emergency power systems must be provided to ensure that critical equipment continues to operate during a power outage. Special occupancies require special attention to electrical safety. By following the NEC requirements for special occupancies, we can protect ourselves and others from the increased risks of electrical hazards. Electrical inspectors must be familiar with the special electrical requirements for special occupancies.